G'day folks, I just wanted to do an introduction to gradient, or the gradient of a line, or the gradient of an interval for Year 11 Advanced Mathematics. This is Cambridge Chapter 6 Part B, Chapter 6B rather. So the formula for, by the end of this video, we're going to examine these juicy little sort of facts or details about gradient. Recall the diagram we had up the other day where we had any 2 points where the coordinates, the x and y coordinates were x1, y1 and x2 and y2. If I want to know the gradient of the interval joining these 2 points, gradient is basically the steepness. How steep is the interval? Steepness is a measure of the rise over the run. Well, remember what we saw yesterday. The rise is the gap in is the difference in the y values. Right? So the rise is equal to y2 minus y1. The run is the difference in the x values. That's x2 minus x1. So the gradient, which is the rise over the run, is y2 minus y1 over x2 minus x1. You saw this formula last year, you saw this in year 10 extensively, right? So how does it work? Well, exactly like the distance formula works, exactly like the midpoint formula works. We have our 2 points. So let's say I've got A, which is the point -3, 4, and B, which is the point 5, 12. Okay, so the gradient is y2 minus y1 over x2 minus x1. I should label my coordinates, so I call this x1, y1, x2, y2, and then I just carefully substitute into the formula. So y2 minus y1, 12 minus 4 over x2 minus x1, 5 minus 3. I get 8 over 8. So the gradient is 1. It's that simple. Okay. I just need to be careful substituting my values and careful of minus signs. And that's it. It's really stick the numbers in and turn the handle, guys. There's nothing, but there's not a lot to using the gradient formula. Okay. What else do we know about the gradient? If you look at the triangle that I drew here, this is a right angled triangle. And I said that the gradient was the rise divided by the run. Let me draw another right angled triangle and we'll look at this divided by that and tell us, and we'll try to remind ourselves rather what this reminds us of. So if I was to draw a right angled triangle and I spoke about this side here and this side here and the ratio of those, well, that'd be good old-fashioned tan theta. So the tan of theta is the opposite over the adjacent. And over here, the rise over the run is the gradient. Well, that means that the relationship we're looking for, the relationship we're looking for is that the gradient is equal to tan of theta. Now, for reasons that we can get into when you ask me questions or a little bit later on, it doesn't actually matter how big the angle that a line makes with the x-axis is. Gradient equals tan theta will always get us out of trouble, except for one case. If I've got a vertical line if I have a vertical line, well, that vertical line doesn't actually have a gradient. Its gradient is infinite, if you like, or its gradient is undefined. We can't talk about how steep a vertical line is, because steepness, remember, is rise over run, and there's no run in a vertical line. So we can't use tan theta equals the gradient, because there is no gradient, and it just so happens that tan of 90 is itself not defined as well. So if you stick tan 90 in your calculator will give you an error. Okay, tan of 90 is undefined. So the gradient equals tan theta always gets us out of trouble if ever we want to know the angle that a line makes or an interval makes with the x-axis. So if we want to know the angle that a line or interval makes with the x-axis, with the positive direction of the x-axis, the gradient is equal to tan of theta. It doesn't matter if our line has a negative gradient or a positive gradient, it doesn't matter. Gradient will equal tan of theta. It always gets us out of trouble. Okay, let's keep on going. If I have two lines that are parallel, so that line there and that line there, if those two lines are parallel lines, they're never going to meet. That's the definition of parallel lines, straight lines that never meet. Well, if this line and this line never meet, they've got to be. We can see it obviously or intuitively. They've got to have the same gradient. If they're parallel, look, they make the same angle with the x-axis, right? Because corresponding angles are equal when lines are parallel. If they make the same gradient, and the gradient is tan of theta, and theta is the same in both cases, then parallel lines have equal gradient. So if I have two lines, I want to know, are they parallel? I ask myself, is the gradient of one line equal to the gradient of the second line? If they are, I've got parallel lines. Okay. And then finally, our last little result is that perpendicular lines that meet at right angles, well, the quality that they have is that the product of their gradients is -1. There's a little bit more trig in that than we probably know just yet, so I'm not going to overly burden you with it. But if I have perpendicular lines, the product of their gradients, the gradient of one times the gradient of the second, is equal to -1. Another way to write this exact same result is to say that the gradient of the first is -1 over the gradient of the second. Now, 1 over a number is the reciprocal of that number. So think about it. 1 over 2 is the reciprocal of 2. The reciprocal of 3/4 is 1 over 3/4. But if we're dividing fractions, so it's going to be 1 times 4 on 3. So the reciprocal of 3 over 4 is 4 over 3. So these gradients are related in that they are the reciprocal of each other. Not just the reciprocal, the negative reciprocal. So if I've got two lines whose gradients multiply to -1, or whose gradients are the negative reciprocal of each other, they're two ways of saying exactly the same thing, then those two lines are perpendicular. So, 2/3 and -3 on 2. They multiply to give me -1. They're the negative reciprocal of one another. Okay? 4 and -1/4. They multiply to give me -1. They're the negative reciprocal of each other. Likewise, a quarter and -4, they multiply to give me -1, and they're the negative reciprocal of each other. They're the gradients with, lines with those gradients are perpendicular. So they're the 4 little juicy facts that we need to take away for the gradient of 2 lines. The gradient is y2 minus y1 over x2 minus x1. The gradient is equal to tan theta. Parallel lines have equal gradients, and perpendicular lines have gradients that are negative reciprocals of one another. I'm sure that that's all the introduction that you need to have a really good go at the exercise 6B or 7B for the extension people in their books on gradient. Make a start and let the exercise itself extend you and challenge you and extend your knowledge. As usual, any questions, any problems, comment below, shoot me a question on Teams, or catch up with me via email or in our next meeting. Thanks a lot, guys.